Welcome. Let us learn one more example on normal distribution. Now the example here is in an examination taken by 500 candidates, the average and the standard deviation of the marks obtained are 40% and 10%. Find approximately how many will pass if 50% is fixed as a minimum. Second question is what should be the minimum if 350 candidates are to pass? And last question is how many have scored above 60%? And again, the areas of some values are given here. Now, let us look into the question. There are 500 candidates. Now, average, that is mean, is 40%. That means we'll get mean 40 by 100, 0.4, and standard deviation is 10%, means we get 0.1. Now what we want is how many will pass if 50% is fixed as a minimum. A student has to score 50% as a minimum marks, then how many will pass out of 500? That is what we want to calculate. Now let us see that the student will score more than 50%. 50% means 50 by 100 will get 0.5. Hence we calculate probability that x is greater than 0.5. Now we'll standardize this variate. X is 0.5. Substituting in the standard normal variate, we'll have 0.5 minus 0.4 divided by 0.1. So we get it as 1. Now probability that x is greater than 0.5 is same as probability that z is greater than 1. Probability that z is greater than 1. Let us take this value as 1 here in the under the normal curve. Then we want the area greater than 1, the shaded portion here. So we can calculate it as total area towards the right side minus area enclosed between 0 to 1. So it is 0.5 minus a of 1, and a of 1 is already given to us 0.3413. Subtract it from 0.5, we get 0.1587. This is the probability that one student will get minimum marks of 50%. Then the number of students scoring more than this or minimum this 50% is 500 into the probability. We get the answer as nearly equal to 79. Because it is number of students, don't write it in terms of decimals. We prefer writing it as a numerical value. Now let us move to the second question here. What should be the minimum if 350 candidates are to pass? Now here the other way is given, that answer this is given to us. 350 students are to pass, then what should be the minimum marks? That is asked here. Now for that we'll go for finding the probability that the student passes after getting minimum marks will be 350 divided by 500. We want the minimum marks as 350. So out of 500, what's the probability that the student will passes? 350 by 500 will get 0.7. Now Z1 be the minimum marks. The probability that we want Z is greater than Z1. The student should score more than this minimum marks. We don't know what that marks is. He has to score minimum marks more than minimum marks. It should be equal to 0.7. Probability that a student scores minimum Z1 marks is 0.7. So 0.5 a of z1 we want here. Probability that z is greater than z1 means z is greater than z1. This shaded area we want. So we'll take it as 0.5 minus a of z1 is equal to, we have 0.7. So this implies a of z1, it is minus 0.2. Area cannot be negative. Now it's already given to us that a of 0.53 is 0.2. A of 0.53 is 0.2. So A of 0.5 is 0.2. So we'll write here Z1 as 0.53. But since the area we have got negative, we will write Z1 as negative. Now this Z1 is the value at some value of X that we need to calculate now. We will convert the standard normal variate into a normal variate again using z equal to x minus mu by sigma. Z is minus 0.53, x we want, mu we know 0.4, sigma is 0.1. Now simplify it, obtain the value of x. X is 0.347. So the minimum marks for 350 candidates to pass is 34.7 percentage. Converting this into percent, we get 34.7% or nearly equal to 35%. Now let us go to the next question. It is how many have scored above 60%? So simple one. How many have scored above 60? We want the probability that x is greater than 60%, that is 0.6. Now if x is 0.6, we obtain z as 2. Now probability that x is 0.6 mean probability that z is greater than 2. Again, if you take this value as 2, we want probability that z is greater than 2. So it is total area towards the right side 0.5 minus a of 2. Now a of 2 is already given to us, so substitute it, simplify, we get probability that z is greater than 2 is 0.0228. Now we want the number of students who score above 60%, so we'll multiply this probability by 500. So we get 11.4, which is nearly equal to 11. That means 11 students will score above 60%.